Hey guys, I just wanted to make this quick video to drum up some business. This is going to be about a extremely cheap, weak signal source, as weak as you want to make it, for optical experiments. So what do we have? We have one of these devices, and I'll throw a picture up here of it. Basically, it's a, what do they call it? Pulse width modulator. If you turn it on, let me see if I can do this right. Yeah, I don't like setting up the tripod for all this crap. But if you turn it on, come on. The right hand controls will set the duty cycle of the square wave coming out, and the left hand side controls the frequency of the square wave coming out. And that drives the LED directly, okay? You can't change the level, but if you want to change the level, you can always put a resistor in series or a potentiometer in series with this and lower the current level. All right. So here's our receiver. This is a run-of-the-mill photodiode that has an integral bandpass filter. I'm running this at 940 nanometers. That's why it shows black and doesn't. I grab my other one here. Really not all that prepared. Here's a standard one, right? Basically what that looks like is just a little tiny solar cell. Okay, maybe 2 millimeters by 2 millimeters. This one with no bandpass filter, okay? This one you can't see. Keeps focusing somewhere else. It's about a half-inch by half-inch square chip, and it's coated with a material or cast into a material that's got an integrated 940 nanometer bandpass filter. Basically what I'm saying is you take this chintzy cheap diode and run it through to your air spy, okay? I don't know how many people have these, but probably quite a few. And you start with SDR console and set it at 20 megahertz, or excuse me, 20 kilohertz, okay? So this is the setup we're going to use essentially. 20 kilohertz, 50% duty cycle, and 9 volts. These things run anywhere from 3 volts to like 35 volts. And the output voltage square wave that sits on this diode is a function of the voltage coming in. Although I've put 12 volts into these, and it does not put 12 volts across the LED. If it did, it would burn out instantly. So here's the setup that I want to show you. This is the exact diode. This diode is from remote control, like a television remote control, something like that. I pulled 812 of these out a long time ago when I worked for the cable company, and I made an array. So this is the world's cheapest, $9.99 for this guy, your 9-volt battery, whatever you have laying around, and a single LED. So let's go see what that looks like from a distance of, let's say, 12 feet away. Okay, so here's what we have. What is it? 20 kilohertz, 50% duty cycle, and there's the LED hanging in free space, pointed 12 feet away from this detector. Now that LED is a really broad, wide angle LED, because you want, in a remote control, you don't have to have it, bore lined right on the television receiver. So not a lot of gain in this LED, and it's a very, very broad, narrow beam width. I'll show you one of the better LEDs later. So there it is. It's at 20 kilohertz, and I'm running SDR console using both the signal strength in the middle. You can barely see it, but you can see that it's in the waterfall. I can't really hear it well. Maybe if I narrowed it up. Okay, so let's go over and just slap a lens in front of this. Okay, just by slapping that one lens in front of it, you can see how much signal gain there is, right? Because now what we're doing, let's see where it started from. It started at minus 110 up to minus 70. Because what we're doing is we're focusing the energy on this entire plane down to that LED. Excuse me, that photodiode. Okay, this other diode has not changed. It's still there. It's still running at the same power level. Now you say, well, if that's got such a wide beam width, why don't we throw a lens in front of that and see if we can narrow it down? Let me set for that. All right, the lens is set up in front of the detector, but again, it's not centered, right? It's not in the focal point. So we're down around minus 90 or so, or minus 100. So I'll try to see if you guys can see this. Here's the lens. And now we have to put this diode in the focal point, just like you would do on a dish. So I'm going to move this back and forth till I find the, there it is. Okay, so I have to lift this up a little bit. It's kind of a cheesy way to do this, but yeah, it keeps falling out of the focal point. Okay, so I don't know if you can see that, but got some signal on there. Let me move this around. Moving it in and out. Now we're up to minus 65, which should put us well above S9. And then I go back and play around with the focal point on this. Okay, it looks like I had that one pretty good. All right, so I'm going to break real quick here, and then I'm going to show you what happens when you use an LED. Excuse me. A photodiode does not have the integral bandpass filter. And before I do say so, we're operating this under full light from all the shop lights, plus all the light that's coming in from behind us, and the sunlight that's impinging on the detector. Okay, this is the other detector. And you see these sidebands over here? They're not really sidebands, it's interference. And it depends on what frequency. There's a whole bunch of crap down there, but it depends on what your lights are outputting. These just have 120 hertz. There's no mix, square wave drive to these, so they're pretty quiet in all the respects. But let's go shut the light off. Okay, so you saw a couple of things happen there. Saw the sensitivity come up, right? Because it's being swamped out by the huge amount of light without that bandpass filter up ahead of the diode. And you saw that extraneous garbage go away. So I'm going to try one more thing here. We're going to leave the lights on just to show you. And again, this is in, tons of light. Just tons and tons of light. So here's a low pass filter. I don't know if you can see. You can see through it. There's like a little bit of red there showing through. So this is a long pass filter. So if we turn, I know people are going to get upset because I'm not using a tripod for this. But in order to do this very quickly, I will zoom in on that. If we look at that noise, the sideband noise, and I take this filter and put it in front of the LED, the photodiode, watch what happens. Okay, signal strength gets stronger. We'll go from an S9 to like 10 over, and those noise bands go away. That's from all the impinging light sitting on top of this LED. I keep saying LED, this photodiode. Okay, it's a quick swap out to the filtered LED. Lenses are still in place. No more junk around the baseline. Now, I didn't align everything again, so very well could be that things are not in line. That's why the signal strength is significantly lower. This is just to show folks how easy it is to screw around with this. Again, no fancy photo preamp, nothing, just an AirSpy receiver and SDR console. So I'm going to do a couple of quick things here. One of them is I'm going to pull away this lens. Okay, so now we see that weak LED, and we're down to about an S5 or so, something like that. I'm going to pull away the collimator on the LED. Pull that out. And what do we have left? Not a hell of a lot, right? Okay, you can still see, right here. You can still see that. And I'm going to try to optimize that by itself because it looks like the LED is pointing downhill a little bit. That's about it. Now, the only thing I'm going to change now is I'm going to change to a different LED. And this LED has a 6-degree beam width, plus or minus 6 degrees to the half power points. So we'll plug that one into the exact same transmitter source over there, and I'll show you how tight that beam width is and how much gain can be gotten just with one of these. The other thing is I have 140 of these LEDs driven by a MOSFET and a square wave generator. That's a crystal clock divided down. And this array draws about 5 amps with a DC signal, 12 volts, and about 2.5 amps at a 50% duty cycle at 18 point whatever it is kilohertz. All right, and one other comment, one other point. I have one of these transmitters that I showed you, right? The little square wave guy sitting out in the barn there. There's the mower deck. Running, I don't know, about a quarter of the power that this LED is running over here, the weak one, the remote control one. All right, so when I'll show you that and the benefits of an optical receiver, take a look inside there first. There's a photodiode amplifier, the photodiode inside of a square metal box, and 12 volts running into a power converter to give me plus and minus 12 for the preamp. All right, but the big point here is I'm going to change this LED. I'm just going to connect it right to the terminals here, and you'll see again, not going to change anything else. There's a very weak signal in there. So let me change it out and I'll be right back. Okay, I purposely have the diode pointed in the wrong direction. And I'm going to zoom in on the display over there. And let's see if we can hear and see the difference. I'm going to sweep across. Okay, here's how much Here's how much I'm moving that. You'll hear it in the background. Here's how much I'm moving that. Okay, so this higher power diode gets almost up to an S7 or so, where the other one was barely perceptible. So let's slap the lens in front of it and see what happens. Now we're over, well, I didn't optimize it properly, but there it is. It's almost 10 over S9. Again, that's with all the lights on and all the ambient sunlight. Just a single diode on one of these little $9 square wave generators from eBay. All right, a quick look in the back of the receiver. Again, 12 volts, power converter to give me plus and minus 12 for this preamp. Now, this is infinitely more sensitive. Let's run over to the display. Okay, so this is a single LED, the weak ones where we barely had a line from 12 feet away. This is at between 175 and 200 feet. And it's shining out towards that shed. So I'll move the antenna here, if you will, a little bit. Okay, I'm going to slightly tilt up. Gone. Drop it back down. So it's really, really tight. So let's take a look at one other thing, right? I'm shooting through two panes of this really, what is it, low IR glass, or yeah, not low IR, low E, whatever the hell it's called. And right now we have a 60, right? Let me open up the window. Oh, just an inch or so on the bottom to get some of this out of the way. Come on, open up. There we go. And there we have a better than 10 dB increase in signal noise, in signal. Opened it up a little bit more. Now we went from, what do we go from? We went from that bottom line. 60, almost up to 40. So that's 20 dB of loss through this glass. Go up a little bit more. And at some point, the ambient light from the outside world is going to swamp that detector. But the point is, that's a single crummy one of those green, those LEDs that I showed over here. This guy, 200 feet away. Now, I could if I open the window completely and let even more light in, watch what happens. Completely swamps out the detector. But if I put a bandpass filter, a tight bandpass filter, this is not that tight of a bandpass filter. This is the exact diode that's in there, by the way. This is not that tight of a bandpass filter. It's rather broad. But if I put a bandpass filter in front of it, like one of these guys, which I can't really do and hold, and the signal will come up another 10 dB because I'm blocking all the ambient light. So let's see, gonna lower the window down. There. 40 over, 30 over. Okay, so I guess that's all I wanted to show. Don't be afraid to mess around with some optical stuff. All you need is a single LED and one of these $9 modules, and a photodiode. Either one like this, or a generic, I don't know, $3 or $4 on eBay for a receiver. And then again, driving it directly into an air spy. One of the nice things about this is there's no question as to what frequency you're on. If you're on 20 kilohertz, guess what? You're on 20 kilohertz. Or excuse me, now I'm looking at my other one that's out there. It's on 18.030 kilohertz, just because of the way the clock is divided. Anyhow, I just wanted to show this stuff so that people could get maybe an inkling of messing around. And again, once you get really rolling, you take 140 of those narrow LEDs, and you got yourself in a incredibly high power LED source. But this is just a beacon for fundamental experiments. So anyway, guys, if you made it this far, I'm absolutely amazed. Thanks a lot. W1VLF from the lab. I'm out.